Now, continuing with our series on advanced steel, we've already mentioned that it allows us to create fairly complex structural models with a high level of detail in a fraction of the time it would otherwise take when working directly with AutoCAD. For example, the model we can observe here, created by our experts at Virginia-learning, was fully generated using advanced steel tools, obtaining not only the overall structural model, but also detailed elements such as connections. These include components like plates, as well as specific types of bolts and welds, all of which have been properly defined within the model. However, another major advantage of advanced steel over traditional AutoCAD workflows is its ability to significantly speed up the generation of detailed drawings for every component in the model. This is possible because advanced steel is capable of recognizing individual structural elements as well as the assemblies formed between them, and then automatically producing the corresponding detailed drawings based on our requirements. Let's take this bridge as an example. Advanced steel can recognize that this structure is composed of a specific set of structural components, such as chord beams, bracing angles, and even the plates and bolts that hold the entire system together. Based on this information, it can automatically generate the required detail views according to a predefined set of rules, or more specifically, a drawing template. What we see here, for example, is a drawing template that has already been configured according to our needs or specific project requirements. Using this template, we can quickly instruct advanced steel to automatically generate the general arrangement and detailed drawings for this bridge structure. As we can see, advanced steel has automatically generated and properly arranged the overview drawings of the selected model, while also adding labels and dimensions based on the defined criteria. This also means that advanced steel can generate drawings with the exact level of detail we require, including only the specific information needed for fabrication or documentation. Additionally, the corresponding tables containing the details of each labeled component have also been created automatically, displaying information such as section type, length, and even weight. In other words, the model is not only being documented, it is also being automatically quantified by the program. So as we can see, advanced steel is not just a tool for creating complex structural steel models. It is a complete platform that connects modeling, detailing, and quantification into a single parametric workflow. At Virginia-learning, this is exactly the type of workflow we focus on teaching, helping you move beyond manual drafting and toward professional, production-ready structural steel detailing using advanced steel. If you'd like to learn more, be sure to visit our website, where you'll find multiple advanced steel courses designed around real industrial projects and practical use cases. And don't forget to subscribe to the channel for more videos in this series, where we explore tools, workflows, and best practices for structural steel modeling and detailing in advanced steel.